Welcome to this explainer. Look, today we're skipping the hype. We're going to let you in on a secret, the remarkably human ways that machines actually learn. It's something most people, honestly, fundamentally misunderstand. We're breaking down the AI playbook specifically for executive decision makers.
Yeah, for sure. Grab your coffee because we're going to look at the exact, tangible strategies these systems use to process data, and way more importantly, how they actually drive real-world business ROI. Okay, let's just dive right into it.
You know, I think the question we're all secretly thinking in the boardroom, but maybe don't want to say out loud, is this. What if AI learning isn't just some mystical black box? Like we hear all these buzzwords and just assume it's pure magic.
Oh, it is definitely not magic, and honestly, framing it that way, it really hurts a company's ability to strategize around it. AI learning is actually a highly structured strategy that, surprisingly enough, closely mimics human education.
Think about it. As humans, how do we learn? We learn by being taught directly with an answer key, right? Or we explore a totally new environment on our own. Or we just use good old-fashioned trial and error.
Okay, so machine learning does exactly the same thing?
Literally the exact same thing. Those human methods map perfectly onto the three fundamental styles of machine learning: supervised, unsupervised, and reinforcement learning. That is the entire foundation of the field. All right, let's jump into section 1, supervised learning, and what we like to call the labeling tax. So whenever I hear the word tax in a boardroom, I immediately think of costs, and you should. It's the most widely used paradigm out there, but it absolutely carries the most direct financial cost for a business. See, supervised learning requires labeled data. That just means every raw piece of input is firmly attached to a correct output. Supervised literally just means a human has already done the exhausting heavy lifting of labeling all the answers. Got it. So it really is just like handing a student a textbook that already has the answer key printed right in the back. The machine studies the question, checks the answer, and learns the pattern so it can predict future answers.
But what does this actually look like in the wild? Can you give me a real-world example of a product we use every day?
Absolutely. Think about Gmail's spam filter. You've got the raw input, the actual text of the email, and the correct output, which is the label of spam or not spam. Google feeds millions, probably billions, of these exact input-output pairs into their model. The model calculates its errors, tweaks its internal settings, and learns that words like one or cheap pills usually mean spam. So when a brand new, unlabeled email hits your inbox, it classifies it instantly. Okay, I get it. The crucial point is that it works, and it works incredibly well. But there's got to be a catch, right? Where is this labeling tax you mentioned?
The catch is a massive bottleneck. We're talking something like 100,000 hours of labor. The machine literally cannot learn unless you have that labeled data. Imagine your company wants to train an AI to detect pneumonia. You need highly paid expert radiologists to sit down and manually label 100,000 individual X-ray images. Thousands of hours of pure human labor. That massive, incredibly expensive human bottleneck is the core limitation and the true ROI cost of supervised learning.
But what happens when you just do not want to pay that tax? Let's move to section 2, unsupervised learning, or discovering hidden value. Okay, this feels like a massive gear shift. What if you have absolutely no labels? How can a machine possibly learn anything useful from just a chaotic, label-free dump of data without any human giving it the answer key?
It's the ultimate question, isn't it? You give the machine this ocean of raw data, and you basically just say, find structure, find anything interesting. It has to discover the hidden patterns entirely on its own.
Picture dropping millions of chaotic customer purchase records into an algorithm. You haven't labeled a single person as a budget shopper or a luxury buyer. But the algorithm uses a technique called clustering. Wait, so you're saying it just notices entirely on its own that customer A and customer D buy similar things, while customer B and E buy high-end tech? Like nobody programmed that specific rule? Exactly. It's wild. It groups similar purchase histories together and suddenly discovers entirely new customer segments that your marketing team didn't even know existed. It is pure, untapped ROI just pulled right out of thin air.
But there is a major executive trade-off you have to understand here. The incredible power of this approach is that the entire internet is basically free, unlabeled data. You don't need to pay those expert radiologists to label anything.
Right, but the challenge seems pretty obvious. The algorithm might group a bunch of customers together just because they all happen to buy blue shirts on a Tuesday. I mean, it's a pattern, sure, but it's completely useless for a business.
You hit the nail on the head. You still desperately need human domain experts to look at those clusters and validate if the machine actually found something actionable.
All right, Section 3, Reinforcement Learning, Trial, Error, and Reward.
Hold on, so in this third paradigm, there's no data set at all? How on earth does it figure out what to do?
Okay, think about training a dog. You don't hand your dog a labeled spreadsheet of house rules, right? You let it try things out. When it sits, you give it a treat, a positive reward. If it misbehaves, it gets a negative penalty. Over thousands and thousands of repetitions, it naturally learns which actions get the most rewards. Reinforcement learning is exactly this process, just for machines navigating a digital or physical environment.
And this specific approach has led to some of the most staggering breakthroughs in human history. Look at DeepMind's AlphaGo. It was an AI tasked with playing the incredibly complex board game Go. No human actually taught it strategy. It simply observed the board, made a move, and got a +1 for winning or a -1 for losing. Wait, so it just played against itself? Millions and millions of times. It constantly updated its own strategy to maximize that reward signal. And because it wasn't biased by human limitations or human habits, it discovered these brilliant, breathtaking moves that human grandmasters literally hadn't thought of in 3,000 years of playing the game.
You know, this actually really resonates with me from a business perspective. The whole exploitation versus exploration dilemma. Because every reinforcement learning AI has to balance these two things. Do I exploit the safe moves I already know will get me a reward? Or do I explore brand new risky moves that might yield a massive payoff? Exactly. It's a constant balancing act. And as an executive, that is deeply human. That's the classic boardroom dilemma, isn't it? Do we stick with our profitable cash cow strategy, basically exploitation, or do we pivot and sink capital into a risky new venture, exploration? Because if you only exploit, you eventually get disrupted. But if you only explore, you go bankrupt. The AI is wrestling with the exact same math we are. Which brings us perfectly to Section 4, Choosing Your AI Strategy. Understanding these paradigms dictates your entire strategy. So let's walk through a definitive cheat sheet for decision makers. If your business goal is to predict precise outputs, like forecasting next quarter's sales or detecting credit card fraud, and you actually have the budget to create labeled examples, you deploy supervised learning.
Right. And if your goal is to find hidden structures or segment your user base, and you're sitting on a massive mountain of raw, unlabeled data, you go with unsupervised learning.
Spot on. And finally, if you're trying to optimize a really complex process over time, think a high-frequency trading algorithm or autonomous cooling for a huge data center, and you can actually build a simulated environment with clear rewards, you use reinforcement learning. But do these ever mix in the real world? Or are you strictly forced to pick just one lane? Oh, they mix all the time in modern AI, specifically to avoid that massive labeling tax we talked about earlier. For example, self-supervised learning is just amazing. The algorithm takes unlabeled data, hides a piece of it, and basically forces itself to predict the missing piece. It generates its own labels. That is exactly how massive large language models are initially trained on the entire internet without humans having to label every single word. And that brings it right back to the tools we literally rely on every single day. Yes, exactly. When you open your inbox, supervised learning is quietly filtering out your spam. When you fire up Spotify, unsupervised clustering is building that personalized Discover Weekly playlist just for you. And when you prompt ChatGPT, you're interacting with RLHF, reinforcement learning from human feedback. Human raters essentially act as that dog training reward signal, teaching the model to be more helpful and safe over time. It's just incredible to see how these fundamental concepts seamlessly blend together to deliver actual value. It really demystifies that whole AI is just magic concept we started with.
That is exactly the goal. AI is a strategy. It's not a magic spell. So to wrap up this explainer, I want to leave you with one final thought, especially considering the immense amount of raw data your company generates every single day. What hidden patterns and what totally untapped ROI is your unlabeled data hiding right now?